Hey there, welcome back to the channel. My name is Chris, and today we're going to talk about edge systems, reliability, and how we can use some cloud technology to make our IoT systems more reliable. Let's just briefly take a look at this product from Microsoft called Microsoft Orleans. Basically, it's designed for elastic scaling for servers for cloud types of applications. And it is based on the actor model, and it has what are called grains and silos. But let's come down and take a look at here. This diagram is kind of what's going to be important for what we're doing. So we've got clusters, grains, and silos. The cluster is a collection of silos, and a silo has a collection of grains. Imagine, if you will, that the grain is a service inside your application. Let's look at this through the lens of industrial IoT. Let's say that we have an application that is looking at a water bath temperature and it has a stack light, right? So we have, say, two services inside of our app, maybe a third that's actually doing action, whatever. But let's just look at, we've got a couple of different things. We've got this temperature sensor reading a water bath and a stack light. That application, we could take each one of those services, the stack light service and the water bath temp thing, and put them into what we're going to call a grain. And this will become a little bit more clear as we move forward. There is a ton of information about how Orleans works in the context of clouds. We're going to use it for something completely off-label. I suspect when they designed and built Orleans, they were not even contemplating what I'm going to be using it for. So we take those services that we have and we wrap them in what's called a grain. You can think of a grain as just a stateful piece. And in fact, I think we've got one up here. This isn't a great diagram, but you can imagine it that a grain is your service in your application that just always exists. You don't have to do anything to create it. You don't have to do anything to destroy it. The Orleans fabric itself will handle all of that. You just say, hey, service, I need you to do something. Those services have a key, a primary key, can be by string. A lot of the detail of how it works is not terribly important to what we're doing. But just think of the grain is the wrapper around our service. Now the silo, imagine that is your piece of hardware, your piece of equipment, not the piece that we're measuring. So if we're talking about the water bath, it's not the water bath. It is the edge device that is monitoring it. So we have a silo is the edge device, and the grain is that service that is reading the temperature, or another grain is the service that is setting that stack light state. And then the cluster here would be your facility. So we've got this facility, maybe it's a cell, whatever. Imagine it though as, let's say it's the facility, and we've got each one of these devices, and inside of them are these services. Now, the way that this is designed is that if a grain fails, or if a silo fails, the overall fabric will reactivate the grain somewhere else. So what we can do is, if we have a silo is a piece of hardware, and if we have redundant hardware, if one of the pieces of hardware fails, it will automatically fail over and start running the application or the grain, your service, on another piece of hardware. If we look at this like in industrial automation, if we are on something like say a RS-485 bus using Modbus, or maybe Modbus TCP, or BACnet, maybe OPC UA or OPC DA, something that has a bus. If we're attached to the bus, we can have multiple pieces of hardware, in our case, these silos, attached to that bus. And the Orleans fabric ensures that only one is ever active. We can have the same, say, Modbus address for each one. So you can have something communicating with the bus. So I've got two different pieces of hardware. This one's communicating with the bus. This one's just silent. And when this one fails, all of a sudden this one comes alive, activates that grain, connects to the bus, and then it takes over. And it does that for you without you having to do any code or any setup. Really, you configure the Orleans cluster, and once you've configured it, it just works. So let's go take a look at this in action, and then let's take a look at the code and how small the amount of work is that you actually have to do to make this happen. What I've got here is some hardware that we're going to use as basically a surrogate to show this. So I've got a pair of Raspberry Pis stacked on top of each other. This LED that's lit up in magenta right now, I'm not exactly sure how it's showing up on camera, but it's magenta for me. This is attached to the lower one, and I've got another one up here attached to the upper. It's a little deceiving because the LED comes up off this board and it comes up off of the header, so it looks like it's above where it is. But this one is for the lower and this one is for the upper. These are both running the exact same application. They are running a grain. Now I'm going to pull the power from the lower one and we'll watch, and it's going to activate on the second. This will take maybe about 15 seconds for activation because it's making sure it doesn't instantly change. It's going to try to ping this other grain a few times, and only after a failure period and a couple of timeouts, it then says, oh, it is no longer working. I'm going to swap over and activate a different grain. So I pull power, and now it has activated this upper grain. And I just plugged in the lower one. We'll let it boot up. And when it comes up, we'll unplug this upper one and it'll swap back. There's going to be a jump cut here because it's going to take time for this to boot and get to the app. I've not done anything to optimize that startup time. And then I'll pull the plug on this other one. All right, so the bottom one is booted. So now let's pull the power on the top one. So that stack of hardware is just over my shoulder here. You can see it right there. And there's the LED for the current state. To make it a little bit more interesting and probably more realistic, I've got an application that would be driving or consuming that. So let's take a look at that right now. So I've got this application that basically it takes one command. I can set the color of that LED. It's an RGB LED, so I can set, 8 different colors if you count off. So if I do, say, color red, color green, you can see it changing right back here, right? And that color, its state is stored. So if we swap to another grain, it's going to take whatever the current active color is, and I can give a command from here and it will send it to whichever grain is active. So if it's the upper or the lower, it doesn't matter. And again, I don't have to do any code to make that decision. I don't have to do any code to tell it to swap grains. None of that. All of that is handled for me. It makes things really, really easy if you're trying to get this kind of reliability through redundancy. Let's take a look at the code for how simple this actually is. The solution really has 3 projects in it. I've got a controller, a core, and a node. Core is just the shared code between the two. Controller is the desktop app that I just showed. And then the node is the application that holds the grains that are running over there on the device. So let's take a look at core real quickly. Basically, I have this interface for the controller grain, and this takes an interface. It derives from grain with string key. The key is the name of the grain. Think of it as the primary key for the grain. Then I have the ability to set the color and get the color. And then the color itself is also in this shared library. But that's it. Our entire shared thing is this single interface. If we take a look at the edge, there are some configuration files, but really I just have 2 things. Well, let's call it 3. I have the entry point, the startup. I've got an output service and the implementation of that LED controller grain. Let's take a look first at the output service. This simply is using Meadow libraries to instantiate a RGB LED, and it handles the turning it on and off. That's all this does. Really, this is just the interface to the physical hardware on that device. This is wrapped by our controller grain. And again, this just implements that interface. So we've got an LED controller grain, and we have some storage and state because it has persistent state. We want, if I yank the power on one, I want the color, the current state, to be transferred to another grain. You can do non-persistent storage where they keep it just in memory, but you would not get that state transfer between the two grains. We have an activate. It goes and gets the state from the grain controller and sets the current color. That's when it's activated. It doesn't worry about how it gets activated. It just says, when I'm activated, do this. And when it deactivates, it forcibly turns the LED off. And then we have our implementation for setting the color and getting the color. And those, again, are just using that state service that we just looked at. And then the program, which is our entry point. Now here, this is just a standard entry point for an iHosting service. So it's going to just create a builder. In this case, we're going to use Meadow, and it's a Raspberry Pi. So this gives us access to that direct hardware. So our pins, so it knows which ones to turn on for each color. And then for setting up Orleans, this is really the setup that we have to do on that edge node. So on our silo, we're telling it what port it's on, what port the gateway is on, and then what our IP address is. And then it just configures with some cluster options. This shows how am I storing that state. Right now I'm using Postgres. Storage of state can get very complex or very simple. You could even store the state on each one of the devices and have replication between them so that you don't even need separate storage. I already have Postgres set up. It's on the small box that those Raspberry Pis are sitting on, so that's what they're using for state. There's some cluster membership options. You notice when I unplugged one, it could take up to about 15 seconds for that state to transfer. That is because of these probe timeouts and the probe limits and things like that. So these control how fast it happens. We could make it much faster, but then it is subject to things like if you're on Wi-Fi, if you get some network noise, things like that, any kind of a timeout would cause the grain to transfer. And then it just waits for the app to shut down. So it just runs forever. And I have this on the devices running as a systemd service. So I just have this service definition file here. You can see it's just being run as a .NET app right here in this location. Now let's take a look at the controller. We have a program, so the entry point and the node controller. Now the entry point, most of this is setting up that UI for us. But you can see we've got the list of gateways, and the gateway in this case is us. It is the desktop application, and then it builds up the user interface. Now the node controller is kind of the interesting piece. We have an Orleans client, which will connect to the gateway. Again, the gateway is ourselves at localhost, so it's going to connect to it, and then it's going to get these services. And this allows it to get the current color or set the color. So when we want to assert a specific state, we want to set a color on that grain, all we have to do is call set color. And you can see that set color is on this LED controller grain. And all we did was we went to the services, we got the cluster client, and then went and got the LED controller grain. And this grain is the same interface from that common. So the grain over here on the edge implements this interface, and all we have to do up at the controller is go out to the client and get that same interface. We don't have to actually build it. In no place did we ever new up one of these. We did not create an instance. Orleans did that for us. We just said, register this grain, and then here we say, go get that grain by interface. And through the magic of whatever Orleans is doing over the network, we get an instance that represents the application running on whatever node that is, wherever it is. And again, we don't even know where it is. I don't know the address of it. I don't know what silo it is running on. I simply say, get the grain and call this method. So I'm going to assert this state and let the Orleans fabric handle however it wants to get over to it. So even though Orleans is designed for cloud-based technology, I think it's an excellent fit to get you reliability through redundancy for IoT systems. The advantage here is, instead of using something like Kubernetes or K3s, we don't have to set all of that up. We don't have to build our services and our REST endpoints or gRPC. We don't have to do any of that. This just all happens. All of the proxying and all of the communication is done for us. We don't have to build any of that. Plus, since it's all interface-based, it's really easy to test. We can mock things. We can run it locally on our desktop, make sure everything's working before we even get to pushing things to an edge device. So if you need reliability for your edge system, one of the best ways that I can think of to do it is to use Orleans. You can duplicate your hardware, double, triple, whatever it is that you need to get the number of nines you need for reliability. Deploy all of those with grains and run your application. You can merge these two technologies together for a really reliable solution, and it never leaves premise. So there's no cloud involved, nothing. I've put all the application code for all of this up in GitHub. I'll put a link down in the description. If you have any questions, go ahead and leave a comment down below or put something over in the repo itself. Otherwise, thanks for watching.